Number one is we're going to pull out a GCF, and the GCF in this case is negative 2x. So I'm going to pull out negative 2x, and that's going to leave me with x squared minus, I got to change my signs, 11x, and then minus half of 84 is 42. So this is where that times table chart really comes in handy here is most people, when they think of 42, they think of 6 times 7 because someone got paid to make you think that. Namely, you're probably your 4th grade teacher. But the numbers we're looking for are actually 3 and 14. So this one winds up shaking out to be negative 2x times x plus 3. And that's that. That's just a standard basic quadratic trinomial. The only thing that differentiates that from an algebra 1 problem is the GCF on the front layer. So that's that. All right, the second question is definitely another GCFer. Remember, they all aren't going to have GCFs. You need to look every time, but that doesn't mean that they'll all have one. So number 2, we're going to pull out an x squared, and then we're going to leave behind x to the 4th plus 5x squared, just minus a regular 36. And this again is kind of cut from the same cloth. It's there. You see now, I think, with obviousness, why we call them quadratic lookalikes. We treat them exactly the same. They have that same structure. Exponent goes even, exponent half as much, none, every single time. So we, in our mind, we factor this just like we would a quadratic. We're still going to build the 2 shells, and we're still, going to divvy. And we're going to follow the same fundamental ideas. They have to multiply to make a negative, so I know I need one of each. And I'm obviously thinking of a 4 and a 9. So I want the plus on the 9 and the minus on the 4, because I want it when I add it to be plus heavy. And then this is one that requires an additional step, right? You guys all see the difference of squares at the end? Right. So we're going to always leave the GCF in front. It just sticks there. The x squared plus 9 is a dead factor. And then this is x plus 2, x minus 2. So that's just what I'll underline for you here in yellow. Remember, that's called the difference of squares. And you're going to see those pop up quite a bit tomorrow. They just show up when they want to. All right, one more in the top row, and that is another GCF. And so we're going to pull out a 2, and we're going to pull out an x. And then we should reveal the actual math problem, which is x squared minus 81. And what is that? It is. It's just a classic simple difference of squares. So that just breaks into x plus 9, x minus 9. And sometimes people say, how do I know I'm done? In this case, you're obviously done because there's no more x squareds or x cubes. So like you're not going to factor down a linear factor. So that's, you're dead at that point. All right, 3 down. Any questions so far? I thought those were pretty straightforward. All right, on to the second row. The first problem, I'm going to pull out a GCF, and it looks like it's going to be negative, and it's going to be 6, and it looks like I can pull out 5 x's like that. I'm going to pull out as much as I can, and then that's going to leave me with just 3 x's, so x to the 3rd. Change the sign to plus, and then 48 divided by 6 is 8. Any questions about that process so far? All right. It'll be a short set, long set, because that's a sum of cubes. And so I personally like to write down what A is. So A is X and B is 2. I know some of you have started to rebel against that. And if you can get it right without it, that's fine with me. It's all good. So I'm going to keep my GCF in front. And then I'm going to build a short set, and I'm going to build a long set. And I'm going to fill it in with my A squared, AB, B squared pattern. Just never changes. So good. Just like that. And again, the only time long set will ever be factorable is if you made a poor choice and chose cubes instead of squares. And I've said, I think at least a dozen times now, that if you're given the option, choose squares. If you choose cubes, there will be stones left unturned. Yeah. Yeah, you can put any and all of these onto your page of notes. I've heard people before just say, I'm going to copy the whole thing into my notes. And I think at some point you oversaturate the usefulness of your notes if you just put stuff in that you don't need. I feel like what Javin said is the smart thing, and that is if I have a problem that I know I don't like, I'm putting that one in my notes. But don't copy all 30. I feel like at that point it's overkill and you lose the ability to see what's important and what's not. But yeah, man, you can put whatever you want on your own page notes. You bet. All right, so that's that for that one. Question number 5 is no GCF this time. So I'm going to just go right away and draw the wall down the middle. I know it's a grouping problem because it's a 4-term polynomial. And because there's no GCF overall, you can see that all 4 of those terms collectively don't share anything in common. So that's where I know I'm ready to go on. So this is the first problem that we don't have to do a GCF. So now we're going to wall it, and then we are going to GCF just the left side, which is x squared. And that leaves behind x minus 1. And then we are going to copy down the plus sign, and we're going to GCF the right side with a 4. And that leaves behind x minus 1. And then we're going to collect it back together. The x minus 1 is the common factor, and the x squared plus 4. And are we done? We are. Pretty happy with how things are going. I hope I feel this way when I'm grading these tomorrow night, but I feel like you guys are really getting the idea of what is and is not factorable. Don't fall for sums of squares. You know I'm going to plant them in there all over the place. Don't fall for my stupid little traps. Remember, squares don't work if there's a plus in between them. It just structurally doesn't work. Not using real numbers anyways. So that one is a completed project. Number 6 does have a GCF of 3, so I'm going to pull that out. And then I'm going to be left with x squared plus 2x plus 1. And this is just another rinky-dink algebra 1 problem with a GCF on front. So this one winds up being 3 times. And then when you build your shells, you realize that, of course, they're both pluses, and the only things that multiply to make 1 are 1s. And I would like it if whenever you can use exponents, if you do, you should. Exponents exist for a reason. So don't ask me the question of, will you mark it wrong? Because I'm just asking politely, would you please write this answer a different way? Don't even bring up the option of, would you mark it wrong? Let's be efficient mathematicians. So this is 3 times x plus 1 squared. Got it? All right, so that's it for row number 2. That is 1/5 of the problems, correct? And I have used, all right, we're about right on pace. So we good so far? Okay, on to the 3rd row we go. And there is no GCF. This is just a standard lookalike. So I know going into it, just to go right away, straight out of the gate and divvy it. Lookalikes have to get divvied evenly like this. And then it's just fundamental algebra 1 thinking. I need 2 numbers that multiply to make -8. One has to be positive, one has to be negative. And I want the balance to weigh heavy on the minus side, because I want -7 to be the result of that little dance they do in the center. Are we done? It's tempting to say no. And again, I want you to know that when I write these, and I've written hundreds of these for all the test versions I've made of this, I don't approach it without thought. I approach it thinking, I'm going to tempt them. Why is x squared plus 1 tempting? X squared plus 1. Why is x squared plus 1 so tempting for some people? Because they're squares. But don't fall for it because it's a plus. And then you get to the second one, and x squared minus 8 is so tempting because it's a difference of almost squares. But 8 is not a square. So there will be temptations sprinkled in with factorable things. Be aware of that. This is done. You can't go any further. Right. We could change some things, you bet. And there's always those little nuancy changes. You bet. We could throw in some x to the thirds. I could change that 8 into a 9. I could change that plus 1 into a -1. There's 20 different things we could do to put some more meat on the bone. But that problem is over. All right. The next one, I'm going to pull out a GCF because that's what I do. It looks to me like I can pull out a negative, and I can pull out a 3. And I can also pull out an x. And that's going to leave me with a positive 16 with 2 x's left And I'm going to switch the sign and I'm going to pull down that. What is that? It is a difference of squares. So GCF just hangs out. And then the difference of squares, if you haven't figured this out by now, look on the bright side. There's still like 23 hours and 45 minutes left. It is just square root of the first term goes there. Square root of the second term goes there. Slap a plus and a minus. Call it a day. Got it? Okay. Next problem is number 9. And number 9 also has a GCF. It looks like it's going to be, is it just 2? I think it's just 2x squared, right? That's pretty, am I missing anything there? No, it's just 2. So 2x squared. And then when I rebuild it, I'm going to have 8x to the third minus 27. And what is this? It is a difference of cubes, so I immediately kick over into short set, long set mode. So A is 2x and B is, yeah. I don't know which one of you guys brought the flies in with you, but there are 2. Can you see there are 2 of them just hanging around my computer here? They're like my little quiz buddies. I'm going to name them Hans and Franz. Oh, there's 3 of them. There's Hans and Franz and Frugal. Hello, guys. Pretty soon I'm going to swat you with this water and squish your guts all over the place. But for now, we are friends. Thanks to whichever one of you little stinky shoot booger drags those flies in here, you little rascals. So 2x squared drops down, and then I'm going to build a short set, long set, and that should be that. So this is going to be 2x minus 3. And this will be 4x squared. I will tell you, having graded this quiz for years, that a hot spot for errors is right where this purple arrow is pointing. So just, you've been warned. A lot of times people put 2x squared there. So remember to square both parts of your A and your B. So anyways, 2x, 4x squared, and then I'm going to go to plus 6x and then plus 9. And again, I know I'm done because long set was good. All right, that's 3 rows down. Are we still doing okay? Number 10, I can tell you, is a very, 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 very hot spot for red ink. Right, don't make the wall, pull a GCF. Words of wisdom spoken by Mr. Cruz back there. So do not build the wall, pull the global GCF first. So when you look at problem 10, you need to pull out a negative, first of all. That's non-negotiable. You don't want to head into a factoring problem with the beginning as a negative. You can, it's just a pain. So pull the negative. And it looks to me like all those numbers can be divided by 2. And that's it. So I'm going to pull a negative and I'm going to pull a 2. And then I am going to completely rebuild the problem, like start from scratch. So that's going to be positive 4x to the third plus 12x squared minus 9x and minus half of 54, like that. So the actual math problem that we want to do is what's in the white parentheses. This is where you now build the wall. So you can put your GCF like physically in timeout. Did I mess up, buddy? What's up? I'm pulling out the GCF always. If it starts with a negative, I'm going to pull a negative, but I'm also pulling out the GCF because there's a 2 in all of them. Right. Then you just build the wall and go in. So basically what I'm about to do is how we started problem 5, because the step I just did in red, I didn't have to do on number 5. Always. That if you don't have that on your page of notes yet, that really should be the first thing, because I'm telling you, it can make or break your grade on this quiz. Every problem, look for a GCF. I'd say probably only 70% of them are going to have them, but that doesn't preclude you from having to look. You still have to look. So now the problem is the white problem. The red thing is just a tag along. And at this point, I'm going to build my wall. And I'm going to GCF the left half, which is 4x squared. And that's going to leave behind an x plus 3. And then I'm going to copy down the minus sign and I'm going to pull a 9. And that's going to leave an X, change the sign 3. And so at this point, if you collect all your pieces, and I have the benefit of using colors, you don't. And so you have to find a way to keep track. Like my GCF, you've been hanging out with me for weeks. You know, my GCF is always red. And I'm trying to keep things color coded because I think it helps. So I'm going to recollect all the parts and pieces. I'm going to bring my GCF down. I'm not going to use colors anymore now. I'm going to bring the GCF down. I'm going to collect the commonality of X plus 3. And then I'm going to collect the leftovers, the green and yellow. Bring it all collectively back together, and what do you see? There's a difference of squares buried there at the end. So we have one more step to do. So -2. Square root plus square root. Square root minus square root, right? Those difference of squares, they're just going to come whenever they want to. It's like, okay, just watch for them. I see a lot of pencils moving on. I see more pencils moving on that problem than I have yet. And that's not a surprise. Like Bryce asked yesterday, where are the tough spots? That's a tough spot. You've been warned. So when there's a grouping and the GCF has to happen first, make sure you make it happen first. Otherwise, you got to go dig it out later, and it's a pain in the booty. You don't want to do that. You can. You don't want to. We good on that? Okay. Number 11 is just pull out a GCF. I think this is just going to be another kind of algebra 1e quadratic. It's probably going to be harder, though, because of the leading coefficient. So I'm going to start by pulling out my 4x. And then I'm going to rebuild the actual math problem, which is 6x squared plus 5x plus, or excuse me, minus 6. And I don't think I recall how this one works, but you guys have worked it out. Remember that problems like this are a little more pooey because there's multiple templates, right? Which template wound up working since you guys have done this? Is it the 3x and the 2x? Okay. And then I want to make a 9 and a 4. So I'm going to stick a 3 over here to force the 9 and a 2 here to force the 4. And I'm going to go heavy on the plus end like that. That -4 plus 9. Yeah, that works. So those are just harder. Ironically, they're the least algebra 2e, but they tend to be the most difficult because there's no formula for that. There's formulas for everything else, but not those. Any questions there? All right, number 12. I'm going to pull out a GCF, which of course, again, is going to be a negative. And I can also see that they're all divisible by 5. And I can also see that they all have at least one x in them. So I'm going to pull that out. And that's going to leave a positive x to the 8th. Change the sign, so positive 15 x to the 4th. And then I change the sign, 80 divided by 5 is 16. Good, good. All right. And again, it's just a lookalike, so don't be scared. It's just keep the GCF and then build your templates, right? So GCF drops down. And then templates we treat it just like a quadratic, but we divvy the x to the 8th and we say half of you go there, half of you go there. And something like this by this point in your math career should be stupidly obvious. You're like, I'm trying to make a 16, but I'm also trying to add to make 15. So you clearly want to stick the numbers really far apart. 16. Yeah, 1 and 16 are your guys. So I'm going to put a 1 and a 16, and then I'm going to think about where I want the heavy part to be, and I want most of it to be plus. So I'm going to do it like that. Good so far? All right, and there's a lot of meat left on this bone. So this is a sort of unique problem in that we're far from done. So I'm going to copy down my GCF, and I'm going to bring my dead factor over to the left. I just kind of like to collect dead factors on the left, kind of keep them all piled that way. Let the tree grow to the right, but no one really cares. And then what is x to the 4th minus 1? Right. It's like a difference of two squares look alike kind of thing. So it's going to break into x squared plus 1, x squared minus 1. So again, I'm forcing dead factors to the left. And then there's yet another difference of squares. So GCF, original dead factor, dead factor from last step, and then new dead factor from this step. And that's that. That's a very, very heavy problem there. That's it for the fourth row. Any questions so far? Okay. 3 more will mark the halfway point. I hope you feel like you're ready to roll. So number 13 has a GCF. Imagine that. And it's going to be negative 5x. And then you probably want to have a calculator handy to help you with the heavier division, like not this first part, x to the fourth, but 1280 divided by 5 is, what is that, 500 something? 500, oh, 300, so 256. Ooh, hello. Got way off the sauce here. And then what do you see? Yeah, it's a big look-alike difference of squares, so there's a lot of meat on the bone. This is actually, I'm surprised I put these back to back. I don't know really how they got shuffled this way, but this is very similar to the problem before. Because 256 square roots into 16. So that's how you can tell there's going to be more meat on the bone after this, because x to the fourth will drop to x to the 2, and 256 will drop to 16. So you know it's going to respawn again. So I'm going to just rock through this. So the negative 5x is going to hang tight. My dead factor is going to be x squared plus 16. My live factor is x squared minus 16. And then we go again. So negative 5x times x squared plus 16. And then x plus 4 and x minus 4. Done. Nice. Next one is just a big old difference of cubes. X to the 9th minus 512 is just, this is one of those ones where if you miss this, then I really kind of go, okay, you're in trouble. Like you're pretty lost. So this is a pretty standard cubes problem. So I'm going to go and get my A. So A is x to the 3rd and B is 8. So short set, long set is going to be A minus B times A squared plus AB plus B squared. Yeah. Right. So final answer, did I have a GCF on this problem? There wasn't one, wasn't there? No. So this is just going to be yeah, so x minus 2. So I need a short set. And then I need a long set, like you said. And then I need the OG long set. And then we're done. Right. You guys okay still? All right, let's do one more and then we'll take a quick break. I'm going to kill these flies and you guys can take a brain break, a listening break. That'll be a win for everyone except Hans, Franz, and Frugal. You know what I'm saying? You've been warned. You could still leave in peace. You could just go fly away to a peaceful place. Go over there by Mason. Mason won't hurt you. He loves flies. Okay, what are they like here? What? Is that what it is? Oh. Holy GCF, Batman. Number 15, I'm going to pull out a negative, and I'm going to pull out a 4, and I'm going to pull out 3 X's like this. And then I'm going to build and be left with x to the 4th. Did I pull out enough X's?
Yeah, 'cause you put for all the 20 years old.
Oh yeah, what an interesting problem. So I pull out -4 x to the third. This is fun kind of redoing these. It's like I'm doing them for the first time. This is fun. So that leaves me with just x to the fourth, sign change 6x to the third, sign change just x, and then sign change 24 divided by 4 is just 6. So split it with the wall. Zoop. GCF of the left side is x to the third, leaving behind x minus 6. Copy down the sign, the plus. GCF is 1, leaving behind x minus 6, which if we recollect everybody, zoom, bring it all back together, we have GCF times the commonality.
Plus 1 and
This is cubes, right? So A is x, B is 1. So we got GCF, dead factor, x plus 1. That's that. Okay, I'm going to take a quick, I'm going to pause the recording and because I don't want to have myself killing flies off the recording. So I'll pause this real quick. All right, halfway home. 16. Oh boy, this is a big quiz. Number 16. Again, the quiz is not this long, so fear not. There's not 30 questions. There's only like 24, something like that. 16. I'm going to pull out negative because I can, and I'm going to pull out x squared because I can. And then I'm going to rebuild, and that's going to leave me with 8 x squared. So it's going to leave me with a sign changed regular x, and it's going to leave me with a sign changed 9. And then it's just factoring 101. What template is going to work here? Is it 8 and 1?
Mm-hmm.
Okay, so we're going to go with an 8x and a 1x, and then we know there's a plus and a minus, and yeah, we want that. That's nice. That's a smooth balance. If you put the 9 there and the 1 there, you get that 9-8 combo, and go heavy on the minus, light on the plus. And that's it. That was a quick one. Number 17. Hey, boy, here's a shocker. There's a GCF. I'm going to divide out a 7 and an x. And I might need your help with some arithmetic as I get going here. So I'm going to leave that as x to the 6th. I'm going to leave that as plus 2x to the 3rd and minus, that's a little shy of 50. So what is that, like 48? I hope. And then it's just a quadratic lookalike. So we'll see. Maybe it'll spawn something interesting. Maybe it won't. So we're going to have x to the 3rd minus 6 and x to the 3rd plus 8.
Can't both those be fast?
One of them can be. Yeah, and again, that first one, when I wrote this one, could have been last year. I don't even remember when I was thinking, let's see who thinks that 6 is a cube. Remember that 6 is not a cube. So that first one feels so different of cubey, and then 6 pops in and says, well, leave me out of this. Like, I'm not a cube. So dead factors are on the left. Right side is an AB short set, long set. So A is x. Well, that's a terrible x. B is 2. And then we're going to hit in there and do some short set, long set action. So GCF, already dead factor, and then new short set, long set, x plus 2, x squared minus 2x plus 4. You guys don't have any questions, do you? You're going to achieve historic greatness on this quiz. I'm going to tell future generations about the time in 2023 when my Algebra 2 kids made my factoring quiz look easy. You will live in infamy. I think infamy is that the right word? I think infamy refers to like a bad thing, doesn't it? Famous is different from infamous. Yeah. So you won't live in infamy. You'll live in fame. Famey. Glory. That's the word I was seeking. Thank you. That was good stuff. This next one, this is problem 18 for anyone keeping score. This is just a big old difference of two squares. So it factors into x to the fourth plus 9 times x to the fourth minus 9. Right? That is what it is. X to the fourth plus 9 is a dead factor. It's a sum of squares. This one factors into x squared plus 3. Done. Right. Number 19 is, that is wacky looking. What in the heck is going on with this problem? I think we're going to want to divide, right? I'm guessing we're going to want to probably divide out like a 3. It just looks like it has a 3. So I'm going to pull a 3, and that's going to be left as a 27x to the 15th, and that's going to be 364. Holy smoked ham on a sausage platter. That's a difference of cubes. So now I got to do AB. So A is 3x to the 5th. B is 4. I think there's that. How can you tell right now that we're going to be done after this step? Because of the 3 and because of the 5. And I mean, there's myriad reasons why we're done. So let's bring it all back together. So we're going to have GCF times short set times long set. And here it is again. Watch out. Long set starts with what? 9x to the 10th plus 12x to the 5th plus 16. So remember to square right there. The number in front of your A or B value also has to get squared when you're doing those bookends on the long set. 20. Number 20 is just a classic grouping problem. And draw the wall. Zoop. GCF, oh, the left half is x squared, x plus 2. GCF of the second half is drop the minus 4, x change sign 2. So collectively it's this. Done? Yeah, you guys, I can't fool you guys. You're good. You're good. You guys are like gifted. What do you think of this answer? It's okay. It's done. However, as I said before, when something can be written with exponents, let's do it. So best answer I can think of is x plus 2 squared times x minus 2. So use those exponents. Use them if you got them. Number 8, nope, number 21 is no GCF. This would be my least favorite problem. In fact, I'm about to have to do it, and I'm not looking forward to it. What does that tell you? So I'm just going to ask for your help on this one. This is number 21. Which template winds up working, 4-2 or 8-1? 4-2 does. So then I know I got a 4x, and I know I got a 2x, and I know my signs have to both be minuses. I got that going for me. And I'm feeling like if I put the 5 here and the 3 here, I'd build a 10 and a 12. So that's that. That almost doesn't belong on an Algebra 2 test, but what the heck? Let's run with it. So 22, number 22 is no GCF. Number 22 is, I think, more evil than number 21. Which template works on problem 22? 3 and 4? Okay, so I'm going to do a 3x squared and a 4x squared. And I know that there has to be one of each, and I need a 9. Is it a 9 and a 5 or a 3 and a 15? So 9's going to go here. and 5 is going to go here. And that's 20 and 27, and I want minus to win. Oh, oof. Done? No, there's a difference of squares. I can't fool you guys. So we have our dead sum of whatever those are, and then we factor down 2x plus 3, 2x minus 3. We've reached the point physiologically, like scientists have proven, that I've long since exceeded how long I should sit here and expect you to listen. So are we doing okay? We've got some problems yet to go, and I'm sorry for that. I know this is really long, but I've got 8 more problems. Are we going to make it? I know for some of you it's easier to just sit and do this. You're very able. I know some of us, like, you checked out 9 minutes ago. So are we okay? I'm killing myself here. This is terrible. I can only imagine what you're going through. So, okay. All right, let's finish this out. So that puts us on problem number 23. 23 is just GCFer. So just pull out that GCF. It looks like I need to pull a negative. Of course, I need to pull a 4, and I need to pull 3 x's. And that leaves me with a x to the 6th and a minus. Don't forget to change those signs. What is that? 64. What is that white thing on the board? It is a difference of cubes, but do not pick that. It is also a difference of squares. So on at least one occasion on the test, I will present you with that opportunity to make a good choice, at least once. So make sure you choose squares. So this is going to factor down as GCF times square root plus square root times square root minus square root. And then you see, holy Toledo, cubes have popped out. So I'm not going to write down A and B this time because I'm getting kind of in a hurry here. The clock's telling me to kick it up. So this is going to be short set, long set, short set, long set. So I'm going to do x plus 2, x squared minus 2x plus 4. And then this one's x minus 2, x squared plus 2x plus 4. And that's a completed piece of work. Good there? Okay. It's interesting, like, you can't tell when you first look at the quiz where there's going to be the meatiest problems. Like, they just show up. Number 24, surprise, surprise, there's a GCF, and it's going to be a negative, and it's going to be a 4, and there's going to be x squared. And that's going to leave us with a sign changed 64, x to the 6th, and a sign changed 1. Yeah, I really did a poor job of scrambling these questions. What again are we faced with here? The dilemma? What is this? It is a difference of cubes, but it's also a difference of squares. So I don't know how they found their way right together like that. So negative 4x squared stays. And then as always with a difference of squares, it's just a pattern. Square root plus square root minus square root. Holy same problem twice in a row, Batman. What? So this is another short set, long set, short set, long set. So we have negative 4x squared times short set times long set times short set times long set. You do see that each of those is cubes. And remember, with cubes, we don't care if it's plus or minus. We're going in. So A and B are 2x and 1. So my short set on the first one is going to be 2x plus 1. My long set is going to be 4x squared minus 2x plus 1. And then for my other one, same A and B, just the plus minus kind of jump around a little bit. So it's still 2x, but then minus 1, and then 4x squared plus 2x plus 1. Right in a row, back to back. Weird. I don't know who wrote this. I do. It was me. All right, 6 more. 24 down, 6 to go. Quickly, what percentage of the practice quiz is left? 20%. Good job. 1/5. 5 out of 30. Good math. All right, number 25 is a factoring by grouping, but I need to start by pulling out the global GCF. The global GCF is going to be a 5 and an That's it. Huh. That was boring. And then 9x to the third plus, what is that? 27 x squared minus 16x minus 48. Yep. And then the collected parts and pieces lend or lead to this 5 times dead factor times. I've had years before where people didn't see that. And I think that this is just, we got a different sort of vibe going this year. I've had years where people see 9x squared minus 16 and don't fact. I'm like, I don't even know what, you guys aren't being fooled by this, I can tell. So this is good. Sorry about my 3. Let me fix that. There you go. Number 26 is there a GCFer there? Looks like a 3 and a negative. Okay, so number 26, I'm going to pull a negative and I'm going to pull a 3.
I pulled 9.
I should have pulled a 9 also. Thanks, guys. It's a good oversight there. So I'm going to pull a negative 9. Thank you. And that's going to leave 4x squared, sign change 16x, and sign change 15. Thanks, guys, for the assist there. And which template works, 4-1 or 2-2? So I want negative 9, and then I want the double 2x template. And that's going to be pluses coming out the Wazowski. And I'm guessing it's going to be a 3 and a 5. Yeah, so that's that. We're going to one more problem, and then I can say we're on the bottom row. And if you're probably 10 times happier about that than I am. So, all right, number 27. I wonder if there's a G. Yep, there's a GCF. So let's pull a negative, let's pull a 3, and let's pull an X. And that leaves us with 9. X to the 4 minus, so sign change 37, X to the 2, sign change 4. And this one reeks of the 9-1 template because 9 and 4 make 36, and 36 is close to 37. So you guys have probably discovered this little trick with or without my assistance, but you know you want to go this route because you want to stick the 4 over here to power play it up to 36. And we want this to go this and like this. What's that? Negative, negative, and then yeah, this is, so we got a pair of difference of squares here. So we got GCF square root plus square root minus square root plus, oops, excuse me, I don't want x squared on that. X square root plus square root minus square root. That's a long one. That's a long problem. 3 more. Number 28 is just a big glorious difference of squares that factors into square root plus square root times square root minus square root, and it is dead. Where'd that little treat come from, huh? Little 4-second problem. Whee! All right, number 29 has a GCF of negative and 6 and x to the 4th. And then I'm going to rebuild as x to the 9th and change the sign. And what is x to the 9th plus 1? It's not a difference of cubes. It's a sum of cubes. And so a is x to the 3rd, b is 1. So I'm going to do short set, I'm going to do long set, and I'm going to go a plus b, a squared minus ab plus b squared. And then you're like, oh, look at this little guy. It's a little sum of cubes. Isn't he a little cute one? Say hello, Cubie. sorry. A plus B times A squared minus AB plus B squared times original. Set out. Done. One more. What is the GCF? All right. What else? 3x. So we pull the 3, we pull the x, and we rebuild into x to the 4 minus 4x to the 3 minus 8x plus 32. We made it. And we made it with like 4 minutes to spare. Boom. Didn't I pull one out? It's here, right here. It's right there. Got proof. Did I skip 29 or?
No, you did. You were right.
No, it's right there. You got to pull out negative 6x to the 4th, and then it becomes the sum of cubes. What did you do? Let me finish this. We had our first little derailment there. I tried to derail us 5 minutes ago when I screwed up the GCF, but we're back on track. Here we go. So the GCF of the left half of this purple wall is going to be x to the 3rd, and that's going to leave behind x minus 4. And then the GCF on the right side is going to be a negative. Make sure you copy that down, 8, and that's going to leave behind an x sign changed 4. And then we're left with collect your pieces, GCF, dead factor, and hey, look, it's another difference of cubes. Little AB guy. So our final answer is 3x, x minus 4, a minus b times a squared plus ab plus b squared. Beth, did you get number 29 figured out, bro? Let me bring it back up here for you, okay? That is the whole problem on the TV right there. No, it's not. Yes, it is. There it is. You good? I gotta wait for Ulysses S. Pokey Pants over here, though. I'm gonna stop the recording, so.